Yeah, welcome to the YouTube for today. What I have for you today is capacitor. We are here to look at capacitor. Before we go into calculation of the capacitor, we have to understand what we mean by capacitor before we start going into its calculation pertaining it. Look at this. We say capacitor is a device for storing electrical charge and energy. It's used to store what? Electrical charge and energy, just like your phone battery. Your phone battery is acting like a capacitor which stores energy and then later you used after the light is off. It consists of two conductors closely spaced by insulated from each other, carrying equal but opposite charge. Look at it. Look at the conductor, positive and what? Negative. And this is called positive plate and the negative plate. If you come here, you will see where I draw it in a skeleton form. So look at it. We said positive plate, negative plate, and this is capacitance. Then this is the charge that flow in the what? Capacitor. The charge that flow in a capacitor is this. Why this is the voltage where that capacitor is being plugged in, which is voltage between the two terminals. The voltage between the two terminals of the what? The capacitor. Why this is the word charge which enters the capacitor. From here we said the quantity of charge which this capacitor will absorb is directly proportional to the applied voltage. Is directly proportional to applied voltage. Quantity of charge which this capacitor will not pick is directly proportional to applied voltage. Then Q, which is quantity of charge, is equals to what? CV. What is C? C is capacitance of a capacitor. Capacitance of a capacitor is CV. Capacitance of a capacitor is CV. And you said where C is a constant of proportionality called capacitance of a capacitor. And this capacitance of a capacitor is the ratio of magnitude of the charge, which is Q, on emitted conductor plates to the magnitude of the potential difference V between them. That is, capacitance is equal to charge over what? Voltage applied to the what? The capacitor. Then we said again that where C is constant for a particular capacitor, capacitance is constant for a particular capacitor, and that's the ability of a capacitor to store a charge is used to what? Capacitance. The strength, the ability a capacitor to what? Store a charge. Just like ability of you to eat a food, a certain quantity of food is your what? Capacitance. So we take where C is a constant of what? Constant for a particular capacitor. Q. And Q is constant for a particular capacitor as well. Charge, which a capacitor will store, is constant. The quantity of charge it will store is constant. And the quantity of charge which a capacitor will also, the capacitance which a capacitor has a quantity of charge it will take. So these two, capacitance and the quantity of charge, are constant. They are what? Constants. They don't what? Vary. While the voltage, which is what? Supply voltage, varies. So capacitance is constant for a particular capacitor. That's what we use to buy capacitor. If you want to buy capacitor, what you are looking at is what? Capacitance of that capacitor. You go there and say, what's the volume? They will tell you it's 240 microfarad. 240, which is the voltage. 50 microfarad, which is the what? The capacitance. That 50 microfarad they gave you is the capacitance, that's the ability of that capacitor. This is what you use to go and buy capacitor in the market for those that repair radio, that's into electronics. So we just say that again, the V varies. Then capacitance C of a capacitor is a measure of a capacitor's ability to store charge and electrical potential energy. It's capacitor ability to store what? Charge. The capacitance is capacitor ability. Capacitance is the capacitor ability to store what? Charge and electrical potential energy. The SI unit of capacitance is coulomb per volume. The SI unit of capacitance is coulomb per volume or farad. This farad is in the honor of Michael Faraday. Michael Faraday is one that discovered the charge. So we use farad as the unit of what? Capacitance, to honor him. Then now, factors affecting capacitance. We are going to look at factors that are affecting capacitance of a what? A capacitor. Then looking at this, you look at a reciprocal of what? Capacitor. We look at positive plate and the what? Negative plate. And this is area of those plates. And this is distance of separation. This D here is distance of what? Separation of the plate. And if you look at that plate, you see this is what we call dielectric in between the plates. Dielectric in between the plates. And this capacitor is what we call parallel plate capacitor. Parallel plate, you look at the plates, they are parallel. Parallel plate capacitor. And we have a coil capacitor, the capacitor that is in a coil form. But this one now, we are talking about parallel plate. The next class we'll begin to talk about types of what? Capacitor. This parallel plate, we say number one, plate area, all other factor being equal. I said plate area. If other factor being equal, greater plate area, the greater the what? Capacitance of a capacitor. The greater the plate area, the greater the what? Capacitance of a capacitor. Look at it. From this formula, we say capacitance equals to what? Area of the plates, epsilon O, which we call permittivity of the what? Dielectric, or permittivity of the medium, where the capacitor is situated. Where this is called what? Distance of separation of the what? The plates. Then you will now see that the more the distance, we say, the more the area, the bigger the area, the bigger this man, because this man is directly proportional to what? Area. Capacitance is directly proportional to area and inversely proportional to distance of separation. Capacitance is directly proportional to area and inversely proportional to what? Distance of separation, which is the separation of the plates. Then we can now say that the plate area, all other factors being equal. What does it mean? You know that it has other factors that are affecting the what? Capacitance of a capacitor. If all of them are kept constant, therefore we can now say that greater the plate area, the greater the capacitance of a capacitor. Reason, the more electric field flows, which is called charge, are stored. You know, when the plates are big, the more the electric field flows, which we are going to store in it. That means the more the area, means the more the stomach, which the person will accommodate, the more the food the person will eat. So as area increase, capacitance of that capacitor increase. Number two, we said plate spacing or distance of separation of the plate, which is D. As D gets small, what happens? We will have capacitance in the greater high. If D is bigger, what happens? The capacitance will reduce. So the more the space, the lesser the capacitance. The closer the space, the greater the capacitance. The more the space is further away, we say the what? Lesser the capacitance. But the more the plates come closer, the more the capacitor. So capacitance. You look at it here, we say all other factors being equal. Further means away spacing gives less capacitance, while closer plate spacing gives greater capacitance. So we see that when it is far away, it gives lesser what? Capacitance. But when it is close, it gives what? The bigger capacitance. Look at it from the formula. You see, as this man, if this man is 6 and this man is 2, what will happen? 3. What of when this man is what? 3. What will happen? 2. You will not see that it will be what? Getting less. So the lesser this man, the higher the capacitance. So we come to number 3. Dielectric material. The dielectric material, look at this signal here, they are called what? Dielectric material. It can be paper, it can be ceramic, it can be paper, it can be pregnated oil, paper pregnated what? In oil. that's oil impregnated what pepper, can be used as a dielectric. Then this ceramic can be used. So this being used is what we call dielectric material. All other factors being equal, greater permittivity of the electric gives greater capacitance, while lesser permittivity of the dielectric gives lesser capacitance. You see that the greater the dielectric, you see that the capacitor can store and retain the charge for long. For a capacitor to retain the charge for long, that means it has a strong dielectric, just like your phone battery. Your phone battery can retain charge for long. Maybe you charge your phone now, you say your phone will last for up to 4 or 5 days before it's run down. It means that that phone, the dielectric of that phone is strong. It has a strong dielectric. Dielectric acts like a what? Acts like a valve, which you will now push in the air, but to take the air out, it will take it gradually, a little by little. That means that dielectric is what? Very, very strong. So the retention of capacitance is based on what? Dielectric, and also the area of the plate and distance of separation. With this formula, you can be able to what? Give these factors that are affecting the capacitance of the capacitor. From this formula, we have area, distance of separation, and EO meaning what? Permittivity, which we call dielectric what? Permittivity. So this is what I have for you today. If you love what we are doing in this class, I believe you subscribe, share, and comment. Your comment will help us to what? Develop. So share this link to your friends and what? Subscribe. Thank you.